Okay, let's do a few examples. Two of them are going to be fairly easy, straightforward. The last one is going to just be a little more difficult. So this first one, it says if angle ACD, so we're looking at ADC, okay, if that measures 23 degrees, which let me get my pen up here, 23 degrees, what does angle ABC measure? Okay, since we know that they share points and they share an arc or an inscribed arc or intercepted arc, excuse me, okay, we know that the relationship between these two angles, the inscribed angle and the central angle, is that the central angle will be double or the central angle or the inscribed angle will be half of what this one is. So all we need to do is we need to just double this one right here. It's straightforward as that. So this one case would be 46 degrees. And algebraically, we could see that this one, we could say that this one is equal to x. And if before we did this, we could say that this one is 2x since it's doubled. All we need to do is 2 times your 23. It's going to equal 46. Okay, and as far as degrees, that would also be how we would label the measure of arc AC. So arc AC is also equal to 46 degrees. Okay, all right, next one. Pretty straightforward as well. It just gives us a little bit opposite information. So if angle ABC, so we're looking at this blue one right here, ABC, if that is equal to 70 degrees, what does the measure, or what does angle ADC, so this green one, what does that one measure? Once again, we could use the same format that we did. If this one is equal to 2x and this one is equal just to regular x, because we know that the inscribed angle is half the measure of the central angle. We could plug in what we know, 2x equals 70, and we divide out each by 2. We're going to get x equals 35. So what is the measure of this angle? Well, the measure of angle ADC is equal to 35 degrees. All right, so now this is on to a challenge problem. This is going to bring in a lot of different information. The question is asked, what is the arc length of AC? Okay, so we know a couple different things here. Okay, we're given the measure of angle ABC. So the measure of angle ABC is equal to 2/5 pi. We could think of that in terms of radians if we wanted to, or just degrees. So with the same logic, we know that the measure of APC, so APC is going to equal the 2 times the measure of angle ABC. Okay, so what we do is we plug this in, 2 times 2/5 pi is going to give us 4/5 pi. Okay, a lot of people would think, hey, we're done. That is the measure. That is the total length of the arc AC. But, well, instead of but, we could say that would be the case if our diameter was equal to 1, but that is not the case. Our diameter is equal to 4. So what we have to do is we have to figure out what our radius is, and then that way we will be able to find out our arc length. Okay, so first thing we need to do is we need to figure out our circumference. Okay, and as we've done a million times before, circumference is equal to 2. Sorry, my 2 looks so bad. Let me retry that. 2 pi r. Okay, so we know a couple different things. Circumference is going to equal 2 times pi, and we know that our r is 4. So and if we times these two together, we simplify it a little bit, is going to equal to 8 pi. So this is our total circumference, okay? We're not trying to figure out our total circumference. We're just trying to figure out the distance or our arc length between A and C, okay? So we can set up a ratio. So we can set this up as arc length divided by our circumference, okay, is equal to the arc measure. So arc measure, which is this one right there. Oh, sorry, I'm getting a little scrunched here. Arc measure, and that's divided by radians. Oops. Radians in a circle. Okay, so we know a couple different things here. We know that our arc length, okay, is going to be 4. Okay, so we know that our arc length, we don't know our arc length yet. That's what we're trying to figure out. Okay, and then what we need to do is divide that by our circumference, which is 8 pi. That's going to equal our arc measure, which is 4/5 pi, divided by how many radians are in a circle. So this is our proportion. We know that there's 2 pi in there. And now what we can do is we can do a couple things. We can, and I'm going to take this arc length and this, I'm just going to call that our measure of AB. So I'm just going to call it, we'll just call it X because we're used to seeing the variable X. Okay, whoops. See the variable X there. And then we can start to simplify things a little bit. Let's simplify this right-hand side. So we've got our X over 8 pi. That's going to equal 4/5 divided by our 2 pi. We can set that up as 4/5 pi divided by 2/1 pi. And, well, first of all, actually, let's go back here. 4/5. So these pi's will actually cancel out. 4/5 divided by 2. We got 4/5 or 4/5 divided by 2/1, and we can simplify that to starting to run out of room here. Okay, we can extend page. That's beautiful. Okay, X divided by 8 pi is going to equal 4/10. All right, now what we can do is we can use cross multiplication. So we're going to be left with 32 pi equals 10x. Okay, we divide by our 10, we divide by our 10, and we're going to get a simplified fraction. So these are going to cancel out. We're going to get 16 over 5 pi equals x, which is our arc length. Arc length of AC. So there we go.